Hi, Dilip.
Hey, Anand.
Good afternoon. How are you doing?
Good afternoon. I'm fine. How about you?
I'm doing very good. How's the weather there?
Nice and humid, man. Like it's 38, 99 humidity.
It's very hot in Hyderabad, but yeah, luckily we don't have the humidity, but it's very, very
Opens up
hot.
all, opens up all your pores.
Okay,
Okay.
so I'm really excited, Dilip, to do this live stream with you, and
Same here.
looking forward to have some real good conversation here and talk a little a bit about my favorite topic right now. That is the Gen AI, how we are actually kind of building. There's so much of information out there, and so many what should I say, good practices, best practices, and bad practices that are whitewashed as best practices all going on. What I want to hear from, what want us to discuss is how we're doing it. How we are actually taking Gen AI to production, putting stuff in production, and actually running with the customers and seeing how it is really making a difference. I'm sure people who are attending the live stream also would love to know more because giving gyan is one thing and actually living it and doing it is totally another thing. So let's get started. Why don't you actually tell me, and to everybody on the stream, what you are doing, what CogniSwitch is doing, how you are actually getting, should I say, everything together? What are your thoughts? Love to know more.
Hey, right, okay. But before that, welcome to everyone on the show. Uh, Thanks for taking the time. Uh, so we would like to kind of give you at least some inputs based on our experiences, not necessarily right or wrong, but what we did and what we learned along the way. And so that's the whole idea. So CogniSwitch, I'm the founder of CogniSwitch. My name is Dilip. And we actually are building CogniSwitch to address a problem which we think is real. Uh, this problem has been haunting me personally for a while, and what we've been trying to do is to see how can we take the knowledge that human beings have and have traditionally found ways and means to share it among themselves. How do they share the same thing with artificial beings, AI? I mean, this was much before GenAI. We have been in stealth for more than 3 years. So basically the idea was, can we take knowledge that the teams share and create kind of a digital twin of that knowledge so that AI, which could also be Gen AI today and something else tomorrow, can potentially leverage that if it is in a rich enough form such that they can do some of the tasks we expect them to do very reliable. So that's the basis for CogniSwitch. Uh,
Awesome.
before I get into, you know, talking more about it, well, it'd be nice if you could also talk a little bit about what you're doing with KISS.
Yeah. Okay. So we are actually on a different kind of mission, pretty much on Gen AI and stuff, but where we are actually helping people develop software using AI. So Kiss AI, or keep it simple with AI. What our thesis is and what we are actually really working towards is, can we help the developers to move faster, reliably? Can they ship software faster using AI, by allowing it to generate code for them, and also do the grunt work of what is software development, which is kind of augmenting them and their capabilities to move faster with the mundane work, so that they can focus on thinking of higher level problems, how they are actually solving bigger problems, how they're bringing diverse systems together. So we want the AI to help them boost their productivity by 100 times. So that's the dream that we are working towards. And obviously, while we do that, there's a bunch of things that obviously are required, right? AI is very creative, but at the same time, uh, we play in the enterprise space. So their reliability, security is super important, and compliance and governance. So with all these words, AI can't take a day off and say, "Oh, today I'm hallucinating." So we are going to actually spend some time giving you bad code is not, kind of allowed. So that's where I think we are dealing with, like you are doing, we are dealing with a tough problem, but working towards that and harnessing and kind of sandboxing the AI in good enough way so that we can build code reliably. So, to kick off the conversation, Dilip, the main topic that we want to talk today is about what stacks are we building or we picking between, the products, how we are actually kind of leveraging them or designing them to make sense of how best our business objectives of our customers is really getting solved. So, I'll pose this question to you. That is, what is the stack that you're building CogniSwitch on? How are you making the choices? Can you throw some light on that?
Yeah, I think one of the things that we learn over time is whatever fancy technology exists, a stack should basically, yeah, reflect the overall architecture you have in mind, and that should actually support the use case that you are going to automate or you're going to build out. So in our case, I think our title of the talk was something more specific, but in our case, what we wanted to do was to look at how we can gather the knowledge that human beings kind of have accumulated over time. And I think for a long time, I think after we came out of the cave, we've been generally using natural language to communicate, to share our knowledge with others, whether it's written or spoken, and allow our next generations to stand on the shoulders, so to speak. OS is a great example of how knowledge has been shared in our domain, and how people have been standing on the shoulders of great guys and building many more creative things, in the future. So what we looked at was, can we, and there are huge sources. I think most enterprises today generate, if you look at the amount of data that's generated, I think
Hmm.
structured natural language sources probably is one of the biggest. And
Hmm.
then, and I was like 80% or above, right?
Hmm.
While you have an ERP and a CRM and all kinds of systems taking care of all the structured, quantitative data warehouses, lakes, now I think there's mesh, whatever you do with it. But basically, that's taken care of.
Hmm.
But there's humongous amounts of, implicit, not so openly spoken wisdom that's sitting inside these natural language sources. So we wanted to look at our primary data source as natural language. So that was
Okay.
one key part of our use case. So when you look at it from an
Hmm.
architecture, the second is once you have a source, and I think people talk about GenAI system. Any system, in my opinion, is it's a it's like an orchestra, various components, but paired and configured so well that you only hear what the conductor wants, the orchestra wants you to hear. Right? Yeah. So
The sum is greater than the parts kind of philosophy.
so so the idea was, so from the point of view of what we had to achieve, we had to take natural language sources of knowledge,
Okay.
and knowing that our teams are becoming hybrid.
Hmm.
When I say it's not working from home and office, I'm talking about working with other beings, artificial beings, right?
Right.
And given how do we take the knowledge that we have and we're kept in some form? Obviously, now it's also digital, it's not in hard copy. How do you ensure that that can be transformed to another form, which can then be utilized by AI? I mean, Gen AI was not what specifically we focused on that time when we were creating this structure. And then so in that system for us, data was one part of it. The transformation was another part of it.
Okay.
After you transform, you need to organize and you need to persist it. You needed a structure to persist that. And after which, obviously, nothing is useful if it just gets persisted and not reused. Right? Reuse is a great thing. So reuse is very important. And therefore, you had to provide another set of components which would allow you to reuse that knowledge that has been stored various ways, whether it's programmatically or otherwise. So that's the kind of thing. The other thing architecturally we looked at was we should be like seamlessly sitting somewhere, invisible, so to speak. It's like plumbing, which would allow us to get plugged in so that these sources can actually provide the necessary plumbing to you take it from a source and provide it where uh, it is required. Pretty much like a smart grid, right? Uh, so
I
that
think
so that
I think
yeah
the two things that stand out to me in what you were saying, right? One is you're building something magical, right? Because the code goes anything any technology that disappears into the background and allows people to use it is magical, and so that's beautiful what you're building. So what are the ways in which I'm sure with this there is tons of data that is actually going terabytes and petabytes of data that is coming in with. What you're doing, how do you actually manage all that, how are you scaling that, how does that work?
Yeah, so typically, I'm sure most people, if that, as you, most people in the audience are technical folks, and if you're dealing with your technical folks would obviously know that if you're dealing with something that's the kind of scale that you're talking about, obviously you need something which is like a queue, which is like a. So for us, the obvious choice, at least in our case, for various reasons, we can get into that, but for us, the choice was Kafka. So Kafka was our queue because we built everything around that. So events happen, things get triggered. There's a way to ensure that everything goes in, you produce, you consume, right? So which is flexible enough. Whether it is, by the way, natural language could be like we said, it could be text streaming, it could be text coming in chunks. It could also be video because there's
Correct.
obviously audio inside a video, which is again natural language. So
Absolutely.
so for us, that was the main block which we chose. And right from the beginning, we said that's something that's going to, and this is something that LinkedIn open sourced, as you know, and used by large enterprises and very innovative startups in different parts of the world. So
Absolutely.
that's
Absolutely.
that on the scale. And when it came to data, like I said, and the excitement about doing this is something being able to gather knowledge and expertise is something that I had worked on in the late 80s. And when I used to work on what is called expert systems, and we would try to gather knowledge and expertise from human beings manually and try to set it up in a system using symbolic, those days called symbolic AI, like it's fashionable today with GenAI. We failed. We failed. I think we failed, and we had an AI winter very soon after that. But I
Right.
think the reason was that we couldn't manually do it. And my excitement with LLMs came when that was a choice. In fact, I would have probably not done, the kind of stuff that I'm doing today without the support of, and the LLMs. Attention is all you need, and the BERT one came out, and that's when
Mhm.
our excitement. So for us, that's also a very important component. You asked me, I'm trying to answer what you said, asked me about the components. And the third thing was we realized a kind of rigid structure like an RDBMS would not help us cater to this kind of grow when you're dealing with knowledge which is dynamic and
Correct.
growing. You get new things. We, we might be wrong, but we felt the architecture like a relational database might not serve the purpose. And so therefore we went for a basic structure which was graph based.
Fantastic. Okay.
These are the main components that we put together.
Awesome. That's beautiful. I think, but then again, symbolic AI is actually supposed to get another resurgence right after the Gen AI wave is kind of peaked. So let's wait for that and see.
Yeah, I think it has always been relevant. It's just that people probably find something new and rightfully get excited about it. While I think all the great things the data scientists and engineers, which was called AI maybe 1.5 years back, is become traditional AI now because of GenAI, right? So, but I think it's just how the market is and how the buzz happens and the hype happens. But I think
It keeps happening. Yeah.
folks know enough to know that that's not what we focus on.
Sure.
All right. So, well, I talked a bit. I haven't finished about my stack, but before I get into other details, let me ask you how did you get about this KISS as a platform, kis.ai as a platform, and what were your choices with respect to your stack, especially when because it's to do with low code, no code kind of situation, and what made you make those choices?
So actually, we don't. Interesting journey we had because me and my co-founders, we have been working in the enterprise space for past 20 years. We have built systems, internal and external systems, scalable systems for quite some time. While we do all that, one of the things that we keep doing, go to every new company, new position, you're again hiring people, you're building systems. We found that we keep doing the same thing over and over. And each of these enterprises also, they actually innovate independently, but again, go back to the same, what should I say, the same building blocks that keep recurring, the recurring themes. Like you said, Kafka, right? So Kafka streams, they've been there forever, but then again, they've kind of packaged it in such a nice way, it actually becomes more like a design pattern. So taking those things, what we realized is the level at which, and we were experimenting with code generation for in our previous roles and even in our company, we have been always looking at AI generating the code in a reliable manner. But then one of the fundamental choices we had to do was at what level of abstraction are we really kind of generating the code? Like we can actually use AI to generate code in assembly and start building from there, or we can actually allow it to generate C code and compile it into an operating system. But the thing is, and you can actually generate HTML and CSS. You can go generate a high-level React component or a Vue component, and so on. So where do you stop? Where do you start? That's basically the choice was something that was very critical for us. And we made a choice that we should not allow AI, or rather use AI to generate at the lower levels of abstraction, because it tends to hallucinate and it cannot give deterministic code. So that's why we actually went higher up on the chain and said, if you are actually building, AI should actually use blocks which are already reliable and which are something you can take to production with. And once those blocks are well defined and they are like Lego blocks, you can actually play with them. You can actually build any kind of scalable application. They're not rigid. They're small, but they're not too small. That kind of blocks, right? Then AI is in a position to actually play with those blocks and build applications. And that's where the developers get, bunch of, should I say, productivity boost, because the AI plays with the blocks, gives them a couple of configurations in which they can build the application, and they pick what suits their needs, and they can coax the AI to actually build much more better solutions. I think that's where that is one of the fundamental things that we have done. So we don't do low code, no code, so to speak, like you said. But what we have done is we have built a platform which looks like a similar platform on which we put the AI layer. So I read somewhere recently that don't treat AI as if it's as smart as a human being, but think of it as a child, and allow the child to play. Right. So what we do is exactly that, saying you have all these building blocks, AI. Please play with them in a different ways. And we of course have the developer, who is the parent, who is looking at those output and trying to see which one makes sense for them, and they are actually taking that to production. So couple of things that we have done there is seeing how do we see that they're reliable, consistent, they don't hallucinate too much, and they are always generating code which can be put into production. And they're also giving complete solutions rather than point solutions or partial solutions. So that's basically how we started building. Going a little deeper into the technology, I think we have used quite a lot of open source LLMs to do this. We have fine-tuned the models to our platform, particularly in the enterprise-y kind of applications and language, in the sense we pre-trained Mistral CodeLama 34B, 7B, 13B, and of course we also tried with 70B. Had mixed too much of resource consumption, but not as much this thing. But we had some fun playing around. So we have trained our models, and then of course we use also LLMs in fine tuning or validating the solution that has been kind of done. We can talk a little more about it, but generally the LLMs are one critical point, and of course we have built the entire enterprise stack blocks, which actually are the foundation on which the LLM sit, and I'll work with the engineers, and that's where they go develop applications.
Yeah, that's amazing. I mean, it's actually, I was thinking while you're talking that how two different, early stage startups doing different things, but has, when the more I hear from you, there seems to be a lot of themes which are common, right? We're talking about knowledge, we're talking about reusing patterns. I mean, that's obviously knowledge with respect to what patterns work, what are handy patterns, what didn't work, right? And these are things which all tech guys know, right? And automating the reuse of that is something which is amazing. The other thing is the foundational pieces that you talked about. For us, the foundational pieces where the basic things that an enterprise operates on, uh, the fundamental facts and knowledge about their products, their services, their processes, right, their policies, their SOPs, right, regulatory oversight. These are things which are like building blocks to run a business, right? And and once you have those blocks, and those are things where, like you said, hallucination is a no-no, right?
Yep.
Once they are in place in a reliable way, then you can let LLMs go play, right? But they're grounded with the necessary stuff. So that's, I mean, just amazing how you're doing something else. We are trying to do something else, but the thinking, even here, I see a pattern, right? Because I think what we are all talking about is there is a place for everything, and
Absolutely. Absolutely.
there's a specific thing that you need for a particular place, and find and choosing that it's not like something shiny. So you have a system and you try to do everything using that shiny tech, right?
Exactly. Right.
So there could be things that for us, LLM is a super duper tool in our tool set when it comes to ingesting natural language sources, transforming them, helping us organize them for a system. Right? In that part, which we call the ingestion part of the pipeline, which is automated, configurable, optimized, of course, configurable. That's LLM plays a key role. Where an LLM is no-no is when you need to retrieve some of those foundation blocks, right?
Correct.
And those will get updated because it's a business, right? It's dynamic. So those blocks are which we protect, which is what is sitting inside the knowledge structure, which I talked about. A graph-based structure on which you have ontologies, taxonomies, which generally help you create a knowledge structure on top of it. Everybody's talking about it. Neo4j talks about it. Tiger Graph talks about it. There are great guys like Dan McCreary, who's actually writing, talking about enterprise knowledge. And I think it's happening in pockets. There are huge amounts of adoption that's happening for some of these technologies. At the same way, I mean, I'm a fan of embeddings and vector. It's not that that's bad, but that and LLMs are not the only thing that's required to solve our use case. We
Correct.
needed embeddings, so we use them very happily. But we also felt that you would need other things, and therefore and then we also ensured where you shouldn't use something based on experience. What happened while building this, we ensured that the foundation blocks need to be handled completely different from how you would do generative stuff in the after you retrieve, and you want to have lots of stuff that you want to do. You generate, you want to create, blogs, you want to create articles, you want to get checklists, you want to make predictions, all kinds of stuff. But you basically would still work on it. So I think the choices are based on the use case and what's your end-to-end pipeline and what's best for the task at hand. I think that's what we all do, right? And that's how
Yeah.
we do.
I actually have a interesting observation. I really like what you said earlier and also even now. That is, you're actually building CogniSwitch also not for just human beings, but you said you're also building that for autonomous agents. So I found that very interesting because that knowledge can also be consumed by agents. So while you were talking and all that, I was going in my own overdrive of actually understanding the technology and how you are building knowledge, like when we do software, right? There's a bunch of validations and business rules and everything that is actually done, or we expect the developers to input, right? But I was just thinking that, when you say the agents are actually kind of pulling that, yeah, maybe we should write a couple of agents which is actually talking to your CogniSwitch and getting all the data and saying, okay, these are all the business rules. You know what? We should actually build the app with this, or maybe there's a white space here. That is why we should go and actually build an app for the business users to be more productive and stuff like that. So looks like a tremendous. I like your thinking that how CogniSwitch is also going, right, saying agents are also users. I think that's one very important should I say mindset that needs to be added when we are building systems these days. That is, autonomous agents and AI agents also will become one of the personas of the software that is coming up. Awesome.
Yeah, I
That's
mean,
really
absolutely. In fact, why just software? I mean, every marketing team that onboards even something as simple as a chatbot, somebody who onboards Copilot. I mean, somebody who onboards an autonomous agent. Now it's 2024 is supposed to be the year of it's an agentic, thing that's going to blow us all out.
absolutely.
All techies are going to die because the agents are going to blow us up. So basically, whatever happens, right? We all live to see the day. But I think the most important thing is how, as human beings, we look at a team which was made up of entirely, whether we like each other or not, it was a team of human beings. Now, if you don't consider that Copilot or don't consider that chatbot as a member of your team, then shit like Air Canada can happen, right? That could be the
Yes,
airline with the best systems integrators in the world doing work for you, but you had a chatbot which went and did something and the court had to say pay money, pay compensation, right? This kind of thing is
absolutely.
not the last thing. I tweeted somewhere that this is not the last we're going to hear something like this. This is because it's not the bot's fault. It is our fault as a team to first not consider that poor thing as a member of our team, right?
Absolutely.
Human
It
beings,
reminds me of the, yeah, go ahead, sorry.
no, go ahead, go ahead.
No, I just got reminded of the Lexus dealership who put a chatbot, and the Lexus dealership was, I mean, that bot was selling Tesla for, to the
Absolutely.
customer who came and said, which Lexus should I buy? It says, no, you should go buy a Tesla. That's a better car.
Just imagine, if you're in an industry like healthcare or insurance or financial services, where you have also regulatory oversight. I mean,
Correct.
it's easy to expect a chatbot to do the things that you would do as a as a being which is like super capable without sharing some of that knowledge. How do you expect this to happen? And that was what was the basis, like I told you, the genesis of what we are doing. But I think the most important thing is, if we manage to do that, then we can decide, okay, these are things that we need to ensure that the hallucination or things like that don't get affected, don't affect the such things. And there are things that you can do which are absolutely beyond that, where you could go to town doing some of those things. So I think it's critical that we make our choices based on and not have like everything is after. So you take RAG, for example, when somebody says RAG, and that's kind of the topic we started on, right? Even for so which is basically retrieval augmented generation. Nothing in RAG says that you have to only use vector databases and embeddings,
Correct.
right?
Exactly.
Nothing there, right? Yes, you need do you need vectors? You need embeddings? Of course, I need it. Without that, my life is miserable in the use case I want to do. But do you just dump it into a vector database and use an index and get out, and then throw chunks of text at an LLM together with some forward question, 4 words which make up a question that the user asked, and first of all use that to find the top K from a vector database, and assume now they are now RAG has become so complicated every day. It's getting complicated every day, and you're gonna make it continue to make it even more complicated. It's worse than your J2E specifications, I think, right? And it's like the problem is somewhere else. The LLM will hallucinate irrespective of what you do with your RAG system. Now you added another component, and the way you're adding it has ensured that there's more issues that you're bringing in because people are starting to realize your top A is not necessarily the top A. But for that context, right? You need
I
data in a richer form. That's it. I mean, I think that's the reason why we chose the foundational block of a graph. And by the way, that doesn't mean we forgot symbolic. We have a decision engine in our platform, and that was also a choice we needed for the use case to run rules and logic which needs to do some stuff beyond what these things could. So I think I would say when you make the RAG or any such choice, I think it's very important to look at the use case, the architecture that would give us the best flexibility, because these things are going to change. Right?
absolutely.
So that's
That is,
my thought.
yeah, I think one of the things I wanted to say also is there was a recent article which was also talking about why there is no unicorn yet, in vector databases, right? So basically, the idea was that if vector databases are all that they are supposed to be, why are they not still at a place where they are actually completely a unicorn or a decacorn, which only on vector databases? So one of the things that I also agree with you very strongly is that data sources, like even traditional search engines, which BM25 algorithms and all, they also do good amount of search. That's why when people say Google is dead and everything, I'm a little skeptical there. The typical traditional search, vector search, and like you said, graph databases and other databases, which are actually the source of truth, that is, all of them are exceptionally important, and that is the more important decision making choice, rather than saying, okay, I need to build a RAG system, so let's go get a vector database first, right? So I think people are also finding it that vector databases are, like you said, they are suitable for a narrow set of use cases. When you're finding proximity, you're finding topics near that, then it makes a lot of, or you're making a hierarchical structure. But there are also times when graph databases and relational databases tables are more important when you're actually doing grounding the AI or the LLM in actual hard cold facts. So completely agree with that. So I have a question, which is more of a follow-on for the same thing, right? Now, in this whole thing, you are actually ingesting a lot of data from the business context, either through videos, audio, I'm sure some amount of human interaction, voice, and text, and bulk of business documents and data and all that. And I'm sure you're inferring all this and making the whole knowledge as the digital twin. Now, I just wanted to you to touch upon how you are actually ensuring the quality of that digital twin. How do you test that digital twin as against what is really there? How do you kind of quality check that? How does that weave into your stack? Just wanted to get some ideas there.
Sure. So, yeah, very good question, and it's not just for what we are doing. It's true for any system that gets built, any product platform that gets built, especially some of the GenAI stuff. We have all of innovative stuff that is being built. So, for us, the biggest thing was there's so much of content out there, which is, I mean, we worked with one of the oldest and the largest professional bodies in the world. Their one standard is 1,800 pages, and these are standards based on which some of the some of the biggest things in this world are built.
Hmm.
So they're terrified with hallucination, right? So obviously, what we have to start. I mean, manually collecting this is something that I know for sure fails because it failed for me in the late 80s. So it's like a no for me. So I said automation is absolutely important, even if it's not 100% perfect, because you're not directly using it to give to a customer. I'm taking a natural language source and I'm using, even if it's an LLM, I know I'm using it to, lift stuff. The other thing is, for most industries, there are taxonomies and ontologies that are available. There is classic NLP. I mean, this is what's great about listening and not having this attitude of my way or highway kind of thing, right? There are great things in NLP that you can still use, right? Which
Yes.
would help to to clear ambiguities, to do reference resolutions. There are tons of things you need to. So that pipeline which I'm talking about is that ingestion pipeline is quite big, right? Quite lengthy and
Hmm.
quite involved and deep, which helps us to do the in each of the steps, the quality. So our one metric for our engineering team is how do you ensure that the transformed knowledge structure that gets created goes up in quality by interventions in each segment of that pipeline, right? Like everybody has
Wow.
metrics, so that's one thing. Second is very importantly, I think if it is knowledge that's come from human beings, I think a human expert exists and has to be in the loop. So we
Okay.
provide mechanisms for curation in different forms. It could be visual. Sometimes the need is to have it in question answer form, sometimes
Hmm.
in paraphrasing. I mean, there are like tons of things that you can do with respect to human in the loop curation. And after that, I mean, there could also obviously some of the industry ontologies and taxonomies also grounds it, right? And we could always run algorithms. We are working on algorithms that can also do validations against even sources which are very specific to that enterprise. So once all that is done, and that's when you can actually publish. And then this knowledge, it's not like just for one use case.
Correct.
Your
Hmm.
SOPs, your processes, your policies, your service or product information is true for multiple use cases.
Correct.
Even for you, you were talking about connecting to CogniSwitch, naming conventions, right? Check-in,
Yes.
check-out procedures, right? There are tons of things we have with respect to even software engineering, right? That's written down already, documented, CMMI level 5, whatever people use, right? So these are also things that could be available for the agent, even when you're generating code. These are written down stuff which can come from sources of knowledge. So I think we're very careful. And when we retrieve, we talked about again quality,
Hmm.
ensure that probability doesn't come into play when you are actually it's a deterministic retrieval. Yeah, there are
Okay.
different ways of doing it. You can have models, graph-based models. You can have different. You can even like there are some great things in RAG happening, which is augmenting the question itself, the request that comes from a user. How do you augment it, and
Hmm.
and, and then use that to do the return? So there are some very good things. It's not that I love many parts of the RAG thing that's coming out. You could pick and
Okay.
choose some of those, but just don't go blindly take a framework. Just we also use Llama Index, and we have actually submitted in the Llama pack with the Llama Index community. We've done the same thing with LangChain, but that doesn't mean that we just go blindly use some framework and just. So you have to pick and choose. Being a engineer, developer, we have to choose and pick and choose our components because that's what makes a recipe and that's what makes your dish palatable for your customer.
Exactly right. I think that is why I think today one of the attention that's getting more due attention, I would say, is towards compound AI. That is systems which are not just models. That is, you just don't build a model and expect it to solve everything, but you are actually intelligently bringing all these components. Like you said, go use a RAG to actually augment the prompt and then go actually feed it to the LLM maybe and get some intents on what you're doing, go get the content, find maybe an embedding, go do something, and then you're actually using another LLM to judge the quality and so on. So obviously, I think there's a ton of attention that's being given to what should I say, how you are kind of building the cohesive solution of using the LLM in a structured manner in a with best practices and everything. So nobody's actually really looking at just one model and saying, okay, I'm going to go with Mistral, or I'm going to go with ChatGPT 4, or once 5 comes 5, and say I'm going to do everything with it. I think you touched upon the right thing, saying how you're designing your entire system, or the AI system, or the compound AI, is going to make all the difference when solutions actually come.
Hey, I had I wanted to ask you this. I said what we did with respect to our use case, but code, like you mentioned earlier also, code generation, especially the deterministic parts, and of course you said talked about how you have a layer on top. Which, how do you ensure that finally the system, the code is in its entirety is what is going to execute, right? Uh,
Yeah.
so how do you ensure that, in your case, how do you ensure that the quality is, you kind of ensure that nothing goes, even if an LLM comes into play, how do you ensure that the code is deterministic enough? Because you're building those qualities at the foundation level. How do you ensure that the system goes?
Like you said, right, ours is also something similar. I think, we have a pipeline. So the pipeline actually goes through multiple levels of AI. So the first, when the user, that is the developer, is always in the loop. And that's the first thing, like you said, the human being in the loop. So what he does is, or he or she does is, they actually give a prompt. And that prompt, if it is a simple prompt, we actually go give it to one of the LLMs to actually start generating the code. Otherwise, what we do is, we actually have another LLM which is going to break down that complex prompt into more simpler prompts. That is like typical chain of thoughts, or tree of thoughts. So they actually break that down into a graph of individual simple prompts, and these prompts then go to narrow AIs that we have built. When I say narrow AI, we are very specific about. So we have built a model which does only API generation. It doesn't do anything else. So it has been fine tuned specifically for actually taking Open API specification, then RAML specification, and generate APIs, or take entities and generate GraphQL APIs, gRPC APIs, and everything, right? And then we have another one which just generates forms. It doesn't do anything else apart from that. So then one which actually kind of stitches everything and does distributed workflows for business workflows. It doesn't do anything else. So what happens is that single prompt of what the application needs to be, we augment that with the context, like you said, where all the business intelligence rules and everything come, and then they're broken down into individual prompts, and that goes to all the multiple LLMs. They generate code individually, and then the whole process starts. We go through, which is very different for us, because we are actually supposed to generate code which compiles and actually runs. So we have to run it through a whole linter chain, compiler chain, and then we have to actually run that with actually compiling and seeing that it works. Then we run through a whole SaaS tools chain, where we are checking the security for it. That is, we don't have a backdoor, we don't have code which is actually going to have some buffer overflows, any of the attack vectors, SQL injection. So all of that SaaS tools actually run. And then finally it goes to a point where AI also generates, why we have another bit of LLM AI, which generates test cases. So all the test cases are run on this application that has been generated. And then the developer actually sees it and says, okay, now I'll actually see what you wrote, which is making sense to me, and what doesn't. And the loop goes on. So that's typically, and of course, we have another, in some cases, we use LLM also as a judge. So we give to three LLMs the same code and say, do you find discrepancies? We also take that input and give to the developer and say, why don't you actually go play with it? So we have to go through all these hoops, because the code, what we found, we go use GitHub Copilot sometimes, and we generate code with it. You know what happens? It generates code, but it hallucinates on the variable. So the variable name here and here is very different. So the code never compiles. So then it is up to the human operator to figure that thing, and it wastes more time than actually saves sometimes. So that's why we have to go through this whole should I say, keeping that rich context and this complex pipeline, and that's how it comes alive. Right? That's when it becomes useful.
So reminds me of horses for courses, right? So like a
Absolutely.
stack of AI fine tuned for specific users that you have even in the pipeline. Right? Wonderful. I think we probably reached. We are on time. I think we said 45 minutes, so we kind of reached the end of our session.
And I
Uh,
didn't know about it. It has
yeah,
been
yeah.
so much fun talking with you, Dilip, that we really ran out of time. And that's good.
Likewise, likewise. So it was fantastic, and it was definitely. I mean, I learned. I kind of assume certain things about your product. Your sharing of knowledge obviously helped me understand definitely more about what you're doing, and I'm sure we'll continue our discussions on some of the things that we talked about. But
That's
I hope we've also been able to help the at least throw some insights about why we went and made some of the choices, and
yeah,
hopefully they can draw some insights from this and utilize that in some of the innovative things that they are building, especially
absolutely.
when they think about a stack for Gen AI use cases that they have in mind.
Lot of learnings for me as well, Dilip, and I really like what you guys are doing. Very exciting. Would love to spend more sessions like this. And to the audience out there, if there is anything specific you want us to cover in the coming sessions, then we would love to know that. Please add your comments. Add your
Questions?
questions. We would love to know if this was helpful, and what else do you think we should cover when we are talking next time. Any specific areas that you want us to cover, anything that we are doing with our products, anything that you are doing, your problems that you want us to talk about, definitely we can take it up.
Absolutely. Yeah. Looking forward to that. And thank you, everyone. Thanks, Anand. And thanks to the crowd for actually participating. Hope you had a useful time. And we look forward to kind of meeting up and having another session with you in the very near future. Thank you.
Thanks, everyone. Thanks, Dilip. And thanks, team.
Thanks, Anand.